Hey guys, today we're going to solve exponential equation. I'm going to explain number 1 and number 2, number 5 and number 6. You're going to do number 3, 4, 7, and 8. Let's start. So for number 1, it says here 4 raised to x over 2 times 4 raised to x over 4 is equal to 4 raised to 9. The first thing that we have to do is to apply properties of exponents. We have to make sure that the left and right side of the equation has the same base. So when we're multiplying with the same base, all we have to do is to copy the base, which is we have a base of 4, we have a base of 4. So 4 raised to, when we're multiplying with the same base, all we have to do with the exponents are added. So we have x over 2 plus x over 4 is equal to 4 raised to 9. Now that the left and right side of the equation are expressed in a single term, next is that we can just ignore the base and just focus on the exponent. Now our exponent is x over 2 plus x over 4 is equal to 9. Those are the exponents of the equation. Now, we are adding two different denominators. What we have to do now is that we have to find their LCD. LCD of 2 and 4. So we're going to list 2 and 4. And then the multiples, we have 2, 4, 6, 8, 10, 12, and 4 is 4, 8, 12, 16, 20. Based on these numbers, what is the least common to 2 and 4? And that is 4. So what I'm going to do here is that I'm going to multiply the whole equation by 4 to the left and right side of the equation. And then 4 times x is 4x over 2. 4 times x again plus 4x over 4 is equal to 4 times 9 is 36. Now I can divide 4 divided by 2, which is 2x, and then 4 divided by 4 is just 1x, or simply x. We have a coefficient of 1 here, is equal to 36. Now I can combine these two because they are like terms. 2x plus 1x is just 3x is equal to 36. Dividing both sides by 3. And our final answer is x is equal to 12. Next, let's go to number 2. So we're going to do the same process. We have the base of 5. I have to express this in a single term, so I'm going to copy 5. And then, what do I have to do with the exponents? Yes, since we have the same base, all we have to do when we're multiplying with the same base is just add the exponent. X plus 3 plus x over 3 plus x over 6 is equal to, copy the right side of the equation, 5 raised to 8. Now that our bases are the same, 5 and 5 on left and right side, I can just focus on the exponents, which are x over 3 plus x over 6 is equal to 8. Now, again, we're adding with the different denominators. So now, what I'm going to do is that I'm going to find the LCD. So we have 3 and 6. So what are the multiples of 3? We have 3, 6, 9, 12, 15. What about 6? 6, 12, 18, 24, 30. So among these numbers, which is the least common to both? 3 and 6, and that is 6. Now, I'm going to multiply the left and right side of the equation by 6 because that's our LCD. 6 times x, I have 6x. 6 times x again. Oh, by the way, this is 6x over 3. 6 times x is 6x over 6 is equal to 6 times 8 is 48. Now I can divide this. 6 divided by 3 is 2x. 6 divided by 6 is 1x, or simply x, is equal to 48. Now I can combine 2x plus 1x is 3x is equal to 48. Divide both sides by 3 to cancel this. So our final answer is x equals 48 divided by 3 is 16. Now pause this video and try to answer number 3 and number 4. Now let's proceed to number 5 and number 6. Let's start with number 5. So as you can see here, this is different from the first two examples because we're not multiplying something on the left side or on the right side. However, the left and right side, the bases are different. This is 27 and this is 3. Now, I know that I can turn 27 with a base of 3, right? And also, one of the trick is that 27 and 3, which is higher? That's 27. So it's going to be hard for me to express 3 with a base of 27. So if get the lower value, so we have 3 here, it means that I want my 27 to have the base of 3. Now, 3 raised to what number gives me 27? Yes, that is because 3 raised to 1 is simply 3. 3 raised to 2 means 3 times 3 is equal to 9. What about 3 raised to 3? 3 raised to 3 is 3 times 3 times 3, which is 27. So 3 raised to 3 will give me 27. So it means that 3 raised to 3 is equivalent to 27. Copy x plus 1 is equal to 3 raised to 2x plus 7. Now, do you remember what we did in the first two examples? Our left and right side of the equation, we already have the same base. So I'm just going to ignore them and I can start focusing on my exponents, which are 3 times x plus 1 and 2x plus 7. 3 times x plus 1 is equal to 2x plus 7. Now we're just solving for x. 3 times x is 3x. 3 times 1 is 3, so I have plus 3 is equal to 2x plus 7. I need to cancel my 2x here. So minus 2x on left and right side. So I can cancel this. 3 minus 2 is just 1x. Bring down 3, 1x or x. And then bring down 7. Now I have to cancel 3 here. So plus 3, the opposite is negative 3. So minus 3, cancel. Bring down. X is equal to 7 minus 3 is 4. So the correct answer is x is equal to 4 for number 5. Let's do number 6. So it's just that we have the same base here. Like the previous example, we have 27 and 3. I already know that, again, since 3 is smaller, I want my 27 with a base of 3. So I'm going to write 3 here. We already know that 3 raised to 3 is equal to 3 times 3 times 3, which is equal to 27. So 3 raised to 3, I'm going to raise that to 3, parenthesis, x plus 2 is equal to 3 raised to 2x plus 5. Now we have the same base, so I'm just going to ignore the bases and then focus on my exponents. I have 3 times x plus 2 is equal to 2x plus 5. Distribute 3, so 3 times x, I have 3x. Distribute 3, so 3 times 2 is 6 is equal to 2x plus 5. Again, I need to cancel my 2x, so I'm going to subtract 2x on both sides. Cancel. 3 minus 2 is just 1x, or simply x, bring down, plus 6 is equal to bring down plus 5. I need to cancel my 6 here, so positive 6, opposite is negative 6, so I'm going to subtract 6 on both sides. Cancel. I'm going to bring down x is equal to 5 minus 6 is just negative 1. So that's the answer here. X is equal to negative 1. So that's it. Try to answer number 7 and number